Okay, so we did our project on electricity and magnetism and kind of like a combination of both of those working together. So our project, we designed a transistor circuit powering and controlling an electromagnet and using current to control the switch instead of manually. So instead of flipping a switch up and down, we were using a current to control it. So what is a transistor? A transistor is similar to a switch, but instead of being a manual switch, such as flipping it up and down or opening and closing it, it's using a small amount of current. So like a train on railroad tracks, you're going to go straight and then you're going to flip something and it's going to divert instead of like manually picking up the train and putting it down. So how does it work? The small base current controls the bigger current, collector current. So the teeny current controls the big current. The teeny current is the switch. When the switch is closed, the small current flows to the base of the transistor. It's just enough to light an LED bulb, or in our case, it doesn't really pick up the metal ball we were using. The transistor that can then enlarge the small current and allow a larger current to flow through its collector to its emitter. And that's enough to light the LED bulb brightly or to actually pick up the magnetic metal ball that we were using, the metal ball. When the switch is open, no base current flows. A transistor amplifies current and can be used as a switch. We used it more as a switch to direct current. So how does it function? There are two types, NPN and PNP. PNP draws current out of the base, and the order is EBC, or emitter base collector. And then NPN, which is more common, it draws current into the base. Order is CBE, so collector base emitter. NPN is more common because PNP is really hard to control the amount of flowing through one of those collectors. You can see the arrow going in or going out. Yeah. Parts of a transistor, there's an emitter, no matter what order, NPN or PNP, it's always to ground. The collector is attached to whatever object you're trying to run where the power is being drained. So in our case, we're trying to run an electromagnet, and the base is responsible for activating the transistor. So it's going to get it to start chugging along. So this is how a basic transistor works. Ours doesn't look this pretty. Ours is much more tangled up and wiry. That's because in our project, our source was a 9-volt battery, and we used a 1,000 ohm resistor. And our first transistor couldn't actually handle all the charge, and it began to smoke and smell, and it was really bad. But we needed a greater transistor that could handle a greater charge, and our new transistor worked well, and it's formatted in BCE, which is neither NPN or PNP, which is a little weird, but it works. So, the new transistor connected to the power source, that little black thing with all the alligator clips, is the transistor. Our electromagnet with some paper clips on it. You can see our circuit with our 9-volt battery connected to our computer and all of our alligator clips going all crazy. And then you can kind of very faintly see a resistor connected to our alligator clips, which has actually ended up connecting to our transistor. And you can see that small red wire is connected to our battery, and that black wire is connected to ground. So what will our transistor do to control the electromagnet? The transistor will act as a switch, allowing charge to flow through the circuit, and the switch is controlled using current, not manually, so we're not flipping it up and down. And we set up a computer to control the power source in the circuit and the length of the magnet. After many trials, our final success was controlling the magnet to attract paper clips, or in our case, the actual video we're going to show you, it's a metal ball for, this is wrong, it's 1 second. It comes up for 1 second and it drops for 1 second because it's 1,000 milliseconds. So I just think they didn't get time to change. Okay. So here we go. We can watch this. Gonna go? Yep, here we go. So you can see it just dropped and then gets picked up and it'll drop. So that's the current going low. And then it's gonna drop again. And then you can see our computer program just running. So, yep, it was really good and it finally worked, which made us all very happy. So, yes, thank you very much.